Okay, so now we're looking at the cosine law. Before we do anything, that makes a lot more sense. So we have the same type of setup as last time, except now we're, I hope it's evident that we're going to be deriving a new formula that we can use for these non-right angled triangles. And so we have our section where we're going to prove what we're going to do, and I've got a few things labeled here. So what I've gone ahead and done is we have a height that's labeled h, and then we have these two terms here, x and b minus x. So we'll recall that the length across from angle b is the lowercase b, so we're going to call this length x, and therefore this length from the center over to A would be the whole length B, subtract that length of X. So that's where those two terms come from. And what we're going to do next is take a look at just this triangle here that I've outlined. And we're going to do a little Pythagorean theorem on it. So we're going to do c squared is equal, well, that would be this length here, which is b minus x, plus h squared. So we say c squared is h squared plus b minus x squared. Okay, so that's our first step. And next we're just going to expand this b minus x squared out. So c squared is equal to h squared plus, when we expand b minus x squared out, we get b squared minus 2bx plus x squared. Now, next, I hope we understand the expansion here. B squared minus 2bx plus x squared. That's just when you kind of multiply that by itself. So, with that being said, we're actually going to take a look at rearranging this a little bit. So c squared is equal to h squared plus x squared plus b squared minus 2bx. I'm just going to forget about that minus 2bx. I don't know that length off by heart. I wouldn't know it given a particular example, but it turns out I don't actually need to know it. Just drawing this left side right angle triangle, we have x, h, and a here, right? And right here we have an x squared plus h squared. Well, isn't that by the Pythagorean theorem x squared plus h squared is a squared? And that's true, so what we can do is substitute h squared plus x squared for a squared. So then c squared becomes a squared plus b squared, and then minus this 2bx. Now, what we're also going to do is take a look at this triangle here, and just take a look at x for a moment. Well, the cosine of c is equal to x over a. And therefore, x is equal to a cosine c. And we're going to make that substitution. So altogether we have c squared is equal to a squared plus b squared minus 2 times b times a cos c, because that's what x is. A cosine c. And now what we have is this different formula that kind of only involves A, B, C, and an angle. And this is the cosine law. More formally, I'll give you the 3 iterations of the cosine law and how I kind of remember them. Because you really only need to remember one. And the rest just come from that. So I'll rewrite this one here. C squared is equal to A squared plus B squared. This is the way I remember it. Minus, it's kind of like the Pythagorean theorem, but then you have a minus 2 times A times B cosine of C. And so the way I remember that is if you're looking for the C length, you have A squared plus B squared minus 2AB. So it's everything so far that doesn't have to do with C in this formula that kind of is just, it's like Pythagorean theorem, but then there's another term that's 2 multiplied by A times B cosine the angle of across from the side length you're looking at. So that's our cosine law. And it applies to the other side lengths too. Let's do B squared. Because B squared is going to be C squared plus A squared minus 2AC cosine B. And so it's very, once you kind of get the rhythm of the general form of this particular formula, the others just kind of come naturally. Go ahead and try A squared. I'll give you a moment to see. Maybe you're thinking about it. Let's go ahead and say that A squared is going to be B squared plus C squared minus 2BC cosine of angle A. And all 3 of these are the cosine law for this particular triangle. Often, that's all I remember anyway, and then I just figure out the other ones from there. Okay, let's try an example out here. We'll do one that's a little more simplistic because kind of know what we should expect for answers. So here's the triangle I have in mind. We have a 30-degree angle here. That's going to be angle C. And we have a side length B of 14. And we have a side length A of 14. Okay, so this triangle, connect there. And we can figure out a lot that has to do with this triangle. Because these side lengths are the same, this is an isosceles triangle, which means these 2 angles are the same. They have to be the same and add up to 150, so we know we're trying to get an angle here of A that's equal to 75 and B that's equal to 75. But let's use our cosine law and actually get that answer to come out of our new formula. So, the first thing we'll do is we'll actually solve for that side length C that we don't know. So C squared is equal to A squared plus B squared minus 2AB cosine of the angle, which is 30. Okay, so C squared is equal to 14 squared plus 14 squared minus 2 times 14 squared, essentially. Cosine 30. Okay, so now when we kind of plug that all in, 14 squared times 2, so that's this. We might want to just account for things as we go, minus 14 squared times 2, so that's minus 392 cos 30. It's going to be equal to C squared. So C squared is equal to 52.52. So therefore C is equal to 7.25-ish. Okay, so there's my answer for C. And now let's take a look at maybe solving for angle A using the cosine law. So if I want to solve for angle A, I'm going to have to use this formula. That's how I would solve for angle A using the cosine law. So let's plug everything in and solve for angle A. So we have 14 squared is equal to 14 squared plus this 7.25 squared, that's this number here, minus 2 times 14 times 7.25 cosine of A. Now we just rearrange this particular formula. So (14 squared) plus our answer squared, and then 14 squared minus that will give me negative 52.518 is equal to negative 2 times 14 times 7.25 cosine A. So now we're going to divide that. You guys can see that on the calculator. So we divide this by negative 2, both sides. And we get cosine of A is equal to the 0.2588 number. We'll inverse cosine. Inverse cosine that, and then hopefully we get, as we claimed before, that A is, yes, 75 degrees. Okay, so I hope that that makes sense and kind of just reinforces what we knew about a particular triangle. However, we'll just solve this one other way. We have kind of using the cosine law. Let's use the cosine law, but then let's also kind of take into account that we also have the sine law here that we might be able to use to solve for an angle. Actually, for this one, I'll solve for angle B using the sine law, just to kind of show that you can do that. So we have B over sine B is equal to C over sine C. And actually, I can kind of flip those around, and I can say sine of B over 14 is equal to sine of C, which is 30 degrees, over that 7.25 number that we solved for in the beginning. So sine of B is equal to 14 sine 30 over 7.25-ish. So that's sine 30 is a half, so we have 7 over 7.25. That's our sine b, and so b is going to be the inverse sine of that. So we're going to do 7 divided by, we'll go up and find that number. And then take the inverse sine of that. And again, we get 75 degrees, which is kind of what we expected. So, lots of ways to do things, whether it be the newly formulated sine or newly formulated cosine law. Hope that makes sense. That should be everything you need to know regarding those two formulas.